Today we are doing FRQ topic 3, rates of change, also called accumulation using rates of change. Most of these are with a calculator, so grab your calculator for this one. There's a key formula to know for all of these rate questions, and it is the fundamental theorem of calculus. When you integrate a rate, you get a change in amount, okay? Fundamental theorem, you know it's going to be there a lot, okay? All right, you will be given either one rate function or sometimes two rate functions. If there are two, usually one is the rate in that something is occurring at, and the other is the rate out that something is occurring at. But in some questions there is only a rate in or a rate out. You will likely be given an initial amount, the amount present at time 0. So the amount in is the integral of the rate in. The amount that came out or that left is the integral of the rate out. Okay? So if you want to find the amount present at a specific time, your ending amount is what you started with plus your amount in minus your amount out. So the initial amount that you have to be given that, plus the integral of the rate in, minus the integral of the rate out. This little guy right here is the thing that kids tend to forget about. If you want to know how much you're ending at, it's going to involve how much you began with, right? Okay. It's also common to be asked the time at which the maximum amount or minimum amount occurred. So maximum, minimum, candidates test. Another commonly asked question involves the rate that the amount is increasing or decreasing at. Okay. You're going to use both the rate in and the rate out for that. Okay. Now, if you want to know if the rate, I said that wrong. You might be asked if the amount is increasing or decreasing at a specific time. For that, you just use the rate in and the rate out. But sometimes they ask you if the rate is increasing or decreasing at a specific time. To do that, you need to find the derivative of the rate. Okay? Rate in, rate out. Okay? All right, so that's a recap of those two very important concepts for these. All righty. All right, we're going to do the one from 2019. We had a very high KHS average that year, much higher than the Texas average or the global average. Got my calculator ready to go. Fish enter a lake at a rate modeled by this function. That is the rate in. That is going to go into my y1, rate in. So y1. Put that in carefully because our answers are almost all going to be involving that. My x is their t. Okay? Fish leave the lake. Fish leave the lake. I'm looking for another color here. Fish leave the lake at a rate modeled by L of t. E for enter, L for leave. I like it. That's going to go in for my y2. Okay, so put that in carefully, double check it, make sure it looks accurate. Okay, I think I got both of those in there right. I think. By the way, make sure your calculator is in radian mode, okay? Alrighty. And let's see. E of t and L of t are measured in fish per hour, and t is measured in hours since midnight. What were we not given here? We were not given how many fish were in the lake at time 0, were we? So we don't know how many are in there to start with, so we'll have to keep that in mind. Part A, how many fish enter the lake? How many fish enter the lake? Does that have anything to do with how many fish left the lake? No. How many fish enter between 0 and 5? Between midnight and 5 a.m. So for part A here, we want the integral from 0 to 5 of the rate in, E of t. Do not bother rewriting E of t. You do not have to write it out like this. Just write it in function form. It takes time and it's unnecessary. So E of t is stored in for my y1. I'm going to go to my home screen, Math 9, 0 to 5, y1 dx. They tell us to round to the nearest whole number. To the nearest whole number, so 153. Okay? If you want to, you can put approximately equal to, or you can just put equal to. It does not matter. Okay? You get full credit regardless. Part B. What is the average number of fish that leave the lake? The average number of fish that leave the lake. Over the 5-hour period from 0 to 5. The average number of fish that leave the lake. Well, how many fish leave the lake? How many fish leave the lake from, oh, I'm looking at the wrong, okay, sorry. I was checking my answers and I realized I wasn't looking at the right answer. I was looking at the wrong problem. There you go. All right, so the average number of fish, if we find the total fish that left the lake divided by the time, we should get the average number of fish, right? Well, the total that leave the lake is the integral of the rate out, yeah? So the integral from 0 to 5 of the rate out, that's our L of t, divided by 5 will give that to us. Okay? All right. Math 9, 0 to 5, y2 divided by 5. 6.059, at least 3 values, at least 3 digits after the decimal point must be shown. Okay? Moving right along, part C. At what time is the greatest number of fish in the lake? Candidates test. Okay, so part C. Candidates test. Our independent variable is time. We want the number of fish. The number of fish, right? I might call that f of t, the number of fish. Okay? We don't know what f of t is, right? But I bet we could find some values. All right. I start with my boundaries, 0 and 8. And now I want when f prime is 0, right? I want for f prime to be 0. F prime is the rate of change of the fish, right? So f prime is the rate in minus the rate out. Rate in minus rate out. So I'm going to go to my y equals screen. I'm going to create a third function, y1 minus y2. And I'm going to see where that is 0. So I'm going to create a fourth function for 0. I'm going to make it so that I don't see the graph of y1 and I don't see the graph of y2, pushing enter on those equal signs. So now we're only going to see y3 and y4. Okay? So I know I need to see from time 0 to time 8. I'm going to go to my window. I'm going to go from time 0 to time 8. Okay, this is a rate of change, right? The average leaving was 6. I don't know what my rates of change will be. I might just make it negative 10 to 10 and adjust it if I need to. Okay, well, negative 10 to 10 was not enough, but it's not enough to see what the whole curve looks like, but it is definitely enough to see where it is 0, right? So I'm going to find where they intersect. So second, calc, number 5 for intersect. What is our first curve? Hit enter. What is our second curve? Hit enter. What is our guess? Hit enter again. You know you're done when it says the word intersection. So t is equal to 6.2035. And I am going to store that in for probably A. I'm not using A anywhere else, so I'm going to store that in for A. So second calc, take that x value and store it in for A. So now my calculator thinks that A is that number. Okay, and I'm going to put A over here. Alrighty. So I'm hesitating because once I saw the graph of the rate in minus the rate out, I'm thinking of another way to do this problem without using the candidates test. But you know what, I think I'm going to finish using the candidates test and then I might talk to you about how else we could have done that justification. So we do not know what f of 0 is. We don't know how many fish were in the pond at time 0. However, I know I can compare these two to that. Whatever that was, I can compare these two to that and find out which was the biggest. Okay? So, using the fundamental theorem, f of 8 minus f of 0 is the integral 0 to 8 of f prime, and f prime is e minus l. So f of 8 is f of 0 plus the integral 0 to 8 of e minus l. And that is equal to f of 0 plus, go to our home screen, math 9, 0 to 8 of, that's our y3, right? So I'm just going to put in y3. 80.919. Oops. Okay. Which is indeed bigger than f of 0. So this is f of 0 plus about 81. Okay? We're going to do the same thing for a. f of a minus f of 0 is the integral 0 to a of f prime. So f of A is f of 0 plus the integral 0 to A of E of t minus L of t. And that is f of 0 plus. I'm going to go scroll up, hit enter right there. I'm going to go to the 8 and change it to A. 135.014. So f of 0 plus 135. Therefore, we were asked at what time. We were not asked what was the greatest number of fish. We were asked at what time is the greatest number of fish in the lake. So therefore, the number of fish is the greatest at time A. Part D. Is the rate of change of the number of fish in the lake increasing or decreasing? Is the rate increasing or decreasing? So we want to know, is the derivative of the rate positive or negative? Okay, so the rate is f prime. That was our E of t minus L of t, right? Is the derivative of that at t equals 5 positive or negative? So is the derivative at t equals 5 positive or negative? We're going to use our calculator for that. Don't do that by hand. Okay, math 8 for derivative, and that's our y3 at time 5. It's negative. Okay, so you could say the value like that, or you could just say is less than 0. Therefore, the rate is decreasing. At t equals 5. Okay, let's see how they scored this one. For part A, 1 point for the integral, 1 point for the answer, 2 points. For part B, 1 point for the integral, 1 point for the answer. It is important to note, you guys, the integral only involved that top part. The integral does not involve the divided by 5. For part C, 1 point for, they said, sets E of t minus L of t equal to 0. 1 point for that. 1 point for the answer. 1 point for the justification. The justification. I started this problem and I finished. My justification was the candidate's test. That was my justification. There is an alternative justification we could have done. We could have said, and I talked about this in this problem, we could have said, because of the graph, because this is E of t minus L of t, right? The rate is always positive until that time, and then always negative after that time, from 0 to 8. So the number of fish is increasing until we get to that time. and the number of fish is decreasing after that time. We could have said that as our justification. Something like E of t minus L of t is greater than 0 on 0 to A. E of t minus L of t is less than 0 on A to 8. Therefore, the number of fish is a maximum at time equals A. We could have said that instead of using our candidates test. Okay? But regardless, we still would have had to do this part. We still would have gotten the answer, and that would have been our justification. Alrighty. And then in part D, the way they scored part D, clearly it's worth 2 points because this every FRQ adds to 9. 1 point for considers E prime of 5 and L prime of 5, which we did, and then 1 point for the answer with explanation. We could have in this problem found E of 5 and found L of 5, and L of 5 is larger than E of 5. That would have done it as well. Okay? That would have meant that the rate in the number of fish is decreasing. Alrighty. So once again, practice, practice, and you get better and better.